A wonderful good afternoon, dear LinkedIners and composites industry. My guests today are Ralf Hedel from Demeta and Yannick Wilhelmin from 90 Labs out of Zurich. Demeta out of France and 90 Labs from Zurich. Welcome, guys. Welcome, Ralf from France. How are you doing?
Very good, Ilkay. Thank you very much for having us today.
You're welcome. Yannick, thanks for joining our show today. You are not on the key position today, but you are helping me out with the comments. So how do you feel today in Zurich?
Very good. Snowy Zurich, and happy to be here to support and to enjoy the session.
Okay, wonderful. So you guys that you are tuning in, once you're tuning in, you will see that my face is unfortunately dark today. I have, put everything, and you can see in my glass, every light is on right now, but somehow the camera doesn't like to show me a more light mood. So please apologize on that one. Just a few rules. If we have an unstable live stream, we are right now also live on Facebook and YouTube. You can go into my channel and watch this live also on YouTube. And if you are coming later in the show or you want to leave earlier, you can always see this LinkedIn Live in my replay on my profile, if you like. Yes. Okay. Yannick, I will remove you for a moment and I will have a private chat with Ralf. And please have a look how the comments are coming in, and I will get you in the show in a few moments. Okay, Ralf. So thanks once again for joining our show. So we had a coaching together on innovation management recently, yep. So in the last quarter, and that was very enlightening because I've got a lot of behind the scenes into, the resin manufacturing, the matrices of composites. But before we go into the nitty-gritty of composites, please would you explain what is your role at Demeta, and let us know what is Demeta in particular.
All right, Ilkay, thank you again. So I'm Ralf Hedel. I'm a Chief Commercial Officer for Demeta. I've been with Demeta for almost 3 years now, after many years in the specialty polymers business. Demeta is a rather small company based in the western part of France, in Brittany, more precisely in Rennes, for those who know this beautiful region. Demeta is a company that has started a couple of years back focusing on the development of catalysts. And based on this catalysis experience, Demeta is developing performance materials and performance chemicals. So we are developing this along two different technology platforms. One is called NEXTENE, which is the key topic for today, and this is what we are going to talk about. And the other technology platform is called Green Care, which is focusing on specialty chemicals. My role is primarily on NEXTENE.
Okay, perfect. So for our guests, Ralf, that are probably not so iterate on resins and matrices, what is a catalyst and what is a resin and what is a matrix? Can you break that down for us, please?
Yeah, of course. So basically, a catalyst is a very specific molecular tool, which is those that infinitesimal range, and it helps to simplify chemical reactions and therefore reducing the processing costs, but also the environmental footprint of the chemical reactions. And basically, catalysts are making chemical processes safer and faster. Now, coming to your question about composites, composite is basically a material that is reinforced with another material. So a matrix is typically a resin that is embedding a reinforcement, and most often it's a fiber reinforcement. Everybody knows about glass fiber and carbon fiber, but there are also other reinforcement types. such as natural fibers, but also minerals, mineral fibers and fillers. So Demeta is developing and commercializing NEXTENE, which is to be used as a matrix for composites. Typically, a composite comprises of about, let's say, between 50 and 70% reinforcement fibers, and the matrix, the resin, is balancing the rest.
Okay, and are we talking here thermosets or thermoplasts with you?
Well, NEXTENE is a thermoset, but as we can maybe discuss later on in this show, we are really at the crossroads of thermosets and thermoplastics, also fluoropolymers in terms of performance. But in terms of, let's say, chemistry, it's a thermosetting resin.
Okay, wonderful. So let me take for a second Yannick into the stream. Yannick, how about the reactions from our community? Do we have already viewers?
Yes, we have over 20 viewers.
Fine. Thank you so much for everyone.
Saying hi to the show guests. And yeah, I mean, no questions from now, but I might start just with a question. Especially interesting field because we are also within the thermoplastic world, and we see a lot of potential in this convergence between properties of thermoset and thermoplast. So what are actually the main challenges on the classic thermosets which you try to actually challenge with your solution, Ralph?
Well, today the industry engineers and the industry designers are looking for materials that are going to perform better. We are more specifically engaged in the high performance composites. And if I take an example of windmill blades, for example, the blades are getting longer and longer. From 20-30 meters a couple of years back to more than 100 meters today. And this is causing both operational problems, maintenance challenges, and manufacturing challenges as well. And today, the resins which are used in this field are, for example, polyester, but most often epoxies. These resins are reaching their limits in terms of processing. Another challenge is that those windmills are going to be placed offshore, and the offshore exploitation of those windmills is causing tremendous and costly maintenance problems, and you really don't want to have too much maintenance costs on those offshore windmills. So it means that you must engage materials that are going to be tougher, more reliable in the long term, and reducing those maintenance costs. Another typical example is in the oil and gas industry, which is drilling deeper and deeper to reach the oil or gas fields. Mm-hmm. And drilling deeper means that to face greater depth, and greater depth means higher pressures. So service pressure is becoming really a challenge for many incumbent materials. Another aspect is that those deep water exploration and production means higher temperatures. And it means that, for example, the typical material, polypropylene or epoxies or polyurethanes are reaching their limits with about 100 degrees, to make it simple. Some of the fields in the deep water E&P are requiring service temperature of more than 120 degrees C, and even sometimes above 140. And this is the typical challenges that we try to solve with our material.
Okay, thanks, Ralph. I guess we have a great question from Jens Bölke. Hi, Jens. Can NEXTENE also be used for pultrusion?
Hello, Jens. Yes, it can. Currently, we don't work on a project directly for pultrusion. We are working on a project which is, let's say, a little bordering with pultrusion, but not a pultrusion project per se. And I will be happy to discuss and develop pultrusion with you. Let's talk after the show.
Okay, wonderful. Thanks for your questions from the community. So I will continue with Ralf, and Yannick, I will come back to you later on. Yeah, for our viewers that are tuning in right now, so this is a LinkedIn live show, and the beauty of LinkedIn live shows is that you can ask your questions in real time, as you have seen with Jens. And please don't be shy. We content creators, we don't like shy viewers. Please ask your questions in the comments below. Also, please introduce yourself. What is your business? Are you in composites? And if you are in composites, what kind of manufacturing processes do you have? Please also link each other. Yeah, ask for connection requests so we can get a nice community here. So the next topic I want to discuss with you, Ralf, is you are in a startup situation and you are coming now with this innovative product on the market, which bridges and addresses some of the problems that are existing on the market. So tell me about a company that is starting up. What challenges are you running through right now, and how are you addressing these challenges?
Well, as a startup company, one of the key challenges indeed to finance our ramp-up phase. Thankfully, we are well supported by our historical shareholders, but also new shareholders. We are also now financed by the European Community. We were awarded a good support from the EIC Innovation Fund last year, and in fact, this is thanks to this EIC that we came across each other and had a chance to work together, Ilkay, last year. So financing is indeed a challenge, but we are doing so far quite good in that respect. Another challenge is to actually screen and select our activities, because as a startup company, we are a small team. We are 18 people now. Most of the team are scientists and R&D engineers and technicians. And with such a small team, the challenge is to really detect the right projects for us, the ones to which we are going to allot resources, human resources and financial resources. So financing, screening the projects, and another challenge, but I would place it a little bit lower on the challenge scale, is to be visible on the supply chain. We need raw material to develop our solutions, and when we buy monomers and comonomers on the petrochemical commodity market, we are obviously, as a startup, a very, very small player, and it's not an easy task to motivate suppliers to provide us with material at a proper price. Also, there we have our successes. We've been able to source and secure our sources for all the main components, but I would place it on the, let's say, top 5 of a startup challenge in the chemical industry.
Wonderful. So when we did the coaching, what was interesting for me was in innovation coaching, I'm looking at the 8 essentials of McKinsey, of course, and then there's this creative phase which you have concluded. You have your business model ready, and now we are going into the acceleration. You have done already your first shipments, and now it's the time to scale up your business, right? And one of the features in your business model is that you are not only seeking to be a raw material supplier or substrate supplier, but you are also a solution provider. That means you are integrating the customer and his requirements into your R&D projects. Can you tell us a bit about this, why you have chosen this route into the market?
Yeah, indeed. We to be successful with our market entry, we need to, as I said, to select properly the project we are going to develop, and to do that successfully, we must really partner with our prospect, with our customers, to develop the right solution. So we are not only supplying drums of resins, but we are supplying solutions. We are supplying application development support. We are supplying HAC support, processing support, support in selecting the right processing equipment, operator training, and so on. And it works quite well. We are engaged in a couple of joint development agreements with big names in the energy sector. Also in the composite sector, we work together with companies like Total, like Saipem, Subsea 7, Technip, and let's say world-class companies in the energy sector. And it's really key to our development, and it's also quite reassuring to see that we have partners like that who are believing in our company, believing in our products, and really having people who are, if I want to use this word, companies that are ready to pay for a new solution.
Willingness to pay, of course.
Not just interest, but let's say ready to pay for a solution.
Yeah, absolutely. So you are basically enhancing and extending the range of composites in mechanical and temperature wise.
Yes.
So regarding the temperature, you had this one case. I don't know whether you can talk about it or not, but in the oil and gas industry, there's a major problem in the temperature range. Can you explain us about that particular environment that is very difficult for composites, for the conventional composites to solve, and what is your solution there?
Yeah, the one of the challenge in the oil and gas sector, especially in the subsea and deep water application, is to face higher temperatures. When pumping oil or gas at very large depth, we are talking about minus 3,000 meters and more. Oil is coming out with temperatures of 120, 140. There is even a well in the Gulf of Mexico where the oil temperature reaches 160 degrees C. So that's obviously a challenge to address, because most of the incumbent materials are simply not operational at those temperatures. But let's say the other challenge that is linked to that is that when the oil is pumped out, it's coming into an environment which is subsea at 4 degrees C. And it means that we cannot, or let's say the oil company cannot let the fluid go down in temperatures. Otherwise, the viscosity of the oil will increase, and you may end up in a clogged pipe. So not only you must resist to higher temperatures, but you also must have a very good thermal insulation of your pipeline, and that's what we believe we have to offer. A material that resists to high temperature, but also can insulate very well.
Okay.
And all this in the optimal, let's say, toughness and life duration circumstances.
Okay, wonderful. That's a fantastic and an extreme application that actually I came across so far. That's the reason why I wanted to make a point and mention it here once again. The thermal properties and the mechanical properties sometimes require also fire protection. Now, you don't have right now, I understand, a fire protective certification because you are a startup, obviously, and fire protection certificates take some time, some preparation. But do you think that fire protectiveness, like in the aerospace, is required, or in the public transport, could be a solution with NEXTENE?
As you mentioned, we have not yet developed a grade that is fireproof, fire resistant. The beauty of the NEXTENE material is that it is using a catalyst technology that is very robust, meaning that the chemical reaction involved in the production of NEXTENE polymer is not disturbed by additives, by moisture, and it's a very robust catalytic system, meaning that we will be able to integrate fire-resistant additives if necessary.
Okay, wonderful. Yannick, do you have any more comments from our viewers?
Yes, I even have 2 questions.
Wonderful.
So let's start. Our friend Oliver Kipf asked a question. He's also working with pultrusion, and he is looking for a technology with a system which could reach TJ over 250 degrees Celsius, so glass transition temperature. Is this conceivable with your resin?
At this time, we have a glass transition of roughly 150, 160 degrees C. But there are many applications where we can work below. We can work, above TG, depending on the application, depending on the environment. But there are many materials that are used above TG. So I would be very happy to discover the application, the service environment to really decline, or on the contrary, be happy to work together with Oliver.
Yeah, Oliver is working on great applications, so sure you will find some interesting potential here. And then another question from Laurent Nicolas. So he is asking about the main difference between your NEXTENE resin and the helium resin from Arkema. Maybe if you can say some words.
I'm not familiar with the very fine details of helium. Of course, I've heard about helium. The main, for me, the main difference between the two resin systems is that is the temperature resistance and the corrosion resistance. I believe that NEXTENE has an advantage there. Helium has other features. It's also a different family of resins. Helium is a thermoplastic, while NEXTENE is a thermoset.
Do you want to show some of your slides, Ralf, while we are in this technical discussion? Maybe some visuals will help better understand your system against this thermoset and the thermoplast that are conventional on the market.
Yes, let me share a couple
Thanks, Laurent, for your question, by the way.
I'm sorry?
I said thank you for Laurent for his question, by the way.
Yes.
And thanks, Oliver, for attending.
Why is it not working?
So now it's coming. Yeah,
it's coming. Yeah, yeah. This is a graph that I like to show. NEXTENE is the green line on this spider web graph, and I like to say that we are really helping the engineers to not making any trade-offs. We combine really good properties of thermosets, thermoplastics, and fluoropolymers. Typically, of course, there is more detail and science behind that, but let's say, roughly said, thermoplastics typically have a very good impact resistance, but a lower modulus and a poor thermal resistance. Thermosets, they have a very good thermal resistance, but they are very brittle. NEXTENE really combines the best. We provide the best of both. We combine a very good temperature resistance up to 140, 150 degrees C service temperature, yet with a fantastic toughness, a rigidity which is for the resin itself around 2 gigapascal, so really similar to epoxy, but much tougher. And that's why I mentioned fluoropolymers. It's also providing engineers, designers with parts that are very tough in corrosive environment. Whatever the media, alkali, acids, the NEXTENE family of resins is really proving superior durability in corrosive environments. Another important feature, we didn't mention it yet, is that it's providing a lower carbon footprint than most of the polymers on the market. This is just a comparison with epoxy. I'm sorry. The carbon footprint compared with epoxy is roughly half of epoxy expressed in CO2 equivalents. Many people will ask why. Why that? And that's, I'm now coming back to the catalyst story of Demeta. Catalysis is really helping to reduce the production pathway and reduce the energy requirements of the chemical reaction, but also the monomers themselves are obtained in a much more simple production path compared to epoxy and all the other technical polymers. So if you want to reduce the carbon footprint of the parts or of your application, NEXTENE is a good solution. Another slide. This one is a little bit busy. It's a little bit busy slide, but with a few icons on the left. I want to emphasize that again, that it's NEXTENE is performing very well in tough environments. When you require high resistance to temperatures, resistance to corrosion, abrasive environment, impact resistance, NEXTENE is the material of choice. Another element that one should not forget is that it's also a polymer with a very low density, around 1, meaning that you can design very tough parts, but keeping a lightweight for this part. As a comparison, epoxy has a density of 1.2, 1.25, and polyester is also higher. Another feature that you see here on this quadrant is the low viscosity. So I'm now more talking to the people who are interested in the processing. NEXTENE can be supplied with an initial viscosity of as low as 10 centipoise. So that's an extremely low viscosity. It's about 10 times lower than most resins. And that really results in faster infusion time. So if you are talking about infusion processes, RTM processes, all the processes where you need to infuse fibers, NEXTENE will help you to reduce your processing time.
Okay, wonderful. Thank you, Ralph, for enlightening us with the features. Now, let me give you some critical question that is coming up lately. So many people think now in electric vehicles will save you a lot of from the carbon footprint. But if we destroy the planet by emitting a lot of carbon, while manufacturing composites, then all the effect is gone. But you have said that you can reduce the carbon footprint in comparison to epoxy by 50%. Is that by chance, or have you, let's say, deliberately developed this feature?
Well, again, back to the history of Demeta with catalysts. Catalysis is one of the pillars of the green chemistry. There is in the Yale University and Professor Anastas has developed, let's say, explained the principles of green chemistry, and catalysis is one of those pillars, because catalysis really helps to reduce the chemical processes, helps to reduce the energy requirements of the chemical processes. So by using catalyzed processes like the polymerization of NEXTENE, you inherently decrease your carbon footprint. So that's one of the reasons. So you can call it by chance, but it's also, let's say, in the genes, in the history of Demeta. And the other reason is that the processing of NEXTENE, the polymerization of NEXTENE, does not require much energy. And it's compared, for example, with the injection molding, where you need to melt plastic pellets to obtain and form your part. The making a part in NEXTENE requires on very, very low temperature, roughly 60 degrees C. It can be done at ambient temperatures. So the incoming energy required for the process is also very low.
So that is one of the reasons, or maybe that reason, because that resonates with me in my heart. I'm a green person, environmental protectionist. That's the reason why I said I need to invite you to my LinkedIn Live, Ralph, in order to make this more known. And also I'm giving you, of course, a platform as a startup to make your products more visible. Okay, Yannick, what's coming up from our audience?
Yeah, I mean, our audience is growing, so we are over 30 now, which is great.
Oh, wonderful. Wait. If we are 30 people, I'm not seeing comments from 30 people right now in the comments. We as content creator, we don't like shy and quiet people. Please write now into the comments from where are you tuning in? How do you like our show? And do you have any questions? Don't be shy. We are just among us, the composites industry. Write it down below. But now to Vasant. What is Vasant asking?
So Vasant is asking, is a phenolic pultrusion possible?
So as answered earlier to Oliver, pultrusion is indeed possible. Could you please precise what you mean by phenolic pultrusion, meaning adding phenolic additives to reduce or to increase fire resistance? Is that
and maybe Oliver, you can maybe also add to that. Do you use any phenolic? I don't think so.
Yeah. Okay, let's wait. What we write in the meantime, we have a great question by Eric Pierjean, our friend from Jack Composites. Hello everyone. Question to Ralph: any recent end-use example application of NEXTENE that you are particularly proud of?
Yes, we have recently qualified our material for body panel applications. We are happy to say that our material can be used as let's say small to medium series body panel applications, for example, in the truck industry or in the construction equipment industry. So we have now qualified NEXTENE, and we are making our first sales there. Another example which is making me more, let's say, particularly proud is that we've been able to produce prototypes of filament wound tanks for compressed gas for hydrogen tanks to be precise, with fantastic reduction of the curing time compared to the current epoxy systems that are used. And not only we are providing a very tough tank with very low level of porosity, but also accelerating the processing. And for hydrogen tanks manufacturers, the processing time is one of the key hurdles from coming to mass production. As you know, today a gas tank is produced by blow molding. There is one tank coming out of the machine every few seconds. While for filament wound tanks, you are talking about hours of processing, including curing time. And this is the key improvement that we are providing to the market.
Right.
let me add a few words. Eric, thank you for this honor here to have you all here on our show. So Eric is the CEO of Jack Group, and Ralph, you will be also exhibiting at Jack Group. I think that will be your first show ever with this solution. Is that right?
Actually, second. We exhibited at Jack 2019.
Okay.
As a startup company, we don't have our let's say a big booth, but we are sharing the Brittany Pavilion.
Yeah.
And it's a good platform for us.
Yeah. Fun fact: my flight ticket, we wanted to meet in Rennes. That was then postponed to the Jack in March, and now it's postponed to June. Eric, may I ask you just to drop a note here? Where can we get access to a free of charge badge for the next Jack show? Please write it down in the comments, someone from your team, in order to get my community a free of charge access to the Jack World that is due, I think, on 3, 2, and 4 June, if I remember rightly. But maybe you can also correct that one. Okay, then I am seeing there is another comment from Sergei Schmidtke. Just a few background because he's only talking in German. Sergei has a company in Nuremberg, and he has a few, nano composite solutions where, nanoparticles can be added to the matrix, and by that you can also increase the mechanical properties. Yes, we have said that once you're using fiberglass and you are adding Sergei's nanoparticles, sometimes there's no need to go to carbon, to upgrade to carbon fibers, because that's sufficient. Then sometimes you don't need really the carbon fibers strength, just add some additives and you will be okay. So look at that also. And Sergei, you may be prepared, and I invite you to one of my future LinkedIn lives if you want to explain that to our audience. Then what we have is Roy is here. Regards from Upper Franconia. Thanks, Roy, for attending. What do you see else, Yannick?
I mean, we had a question from Jens, but coming back to the wind blade production business, because he sees also great opportunity leveraging on the low viscosity of your resin to help save hours in the infusion process. But and he was asking if that's actually a future field for Demeta, but obviously, Ralph, you already shared about this being a clear target of your business.
Indeed, yeah.
So, and is there any other businesses or application on your wish list which you don't have now, but you would like to get a grip on?
I can share maybe a slide here to explain where we are active. If you give me 1 second.
Sure. Eric Pierre-Jean is commenting that Brittany is very innovative, so looking forward to see Demeta as a award winner on the next Jack show.
Oh yeah, we should suggest actually Demeta for the Jack Award. That's right, Yannick. That's cool. Yeah,
it's a good idea. Indeed, Brittany is very innovative. I'm from the north of France, so I can really freely say that.
Yes.
I was really impressed by the innovative spirit of my fellow compatriots out west.
But we don't want to influence the jury, Eric. Yeah, we are just proposing.
Yeah, you were asking me about other applications.
Yes.
Let me show you just to simplify for the viewers. Can you see these 3 blocks here?
Yes, we do.
Yeah. So I mentioned oil and gas. It's indeed one of our key target markets at the moment, with great partnerships with industry leaders. We are member of Evolen, which is the French Association of Petroleum Industry players, and we have great joint development agreements with them. I named a few earlier. So Total, Saipem, Subsea 7, Vallourec is also involved there, and Technip. I hope I don't forget anybody. Maybe I do. but sorry if it's the case. So together with them, we are developing a solution for pipe and field joint coating, but also custom coating. So that custom coating is let's say the name for developing especially thermal insulation solutions for very complex parts that are used subsea. We have also a program to produce composite risers through an interesting process, either of the classic filament wound pipes, but we also believe that thanks to our technology, we can advantageously infuse threads of carbon fiber. And that's an interesting project there, for which we are still looking for partners. So anybody interested in developing lightweight pipes or hollow structures with carbon fiber, please contact us. Performance composites is indeed a key area. We have a program in hydrogen tanks, an interesting program also to develop concrete reinforcement bars. Most of us know the very typical steel rods which are used to reinforce concrete. Together with a German partner, we are developing reinforcement bars with carbon fiber and glass fiber that helps to really create innovative buildings and civil engineering items. Another feature for NEXTENE, which I did not mention so far, is the very good transparency to electromagnetic waves, meaning that we can, together with NEXTENE, produce high-performance radar domes, 5G equipment. And then on the right side, you see a block that I call industrials. That's, let's say, a more generic application segment in which you can find body panels, ballistic protections, and some interesting application in the nuclear depollution.
Ralph, some of your messages are showing up on the screen. Please be aware that for data protection, I've removed your screen right now.
Okay, it's also the message saying that I'm low on battery. So if you give me 1 second, I will.
Yeah, I give you 1 second. I'll continue with Yannick for a minute. So Yannick, what do you think about this solution? What is your first assessment? Give me your expert opinion on this.
I mean, I was already speaking with Ralph beforehand, and I would be interested to actually challenge this material on 3D printing. So let's make a tape out of it and test it in our 3D printers, because I guess it's always a good way to go into very innovative applications. I would like to try it on some medical applications, because it was not mentioned here on the slide, but I see some potential, especially if it's if it has good properties in terms of X-ray transparency, etc. That could be an interesting field, because sustainability is also becoming more and more important here, and material efficiency could be brought by the 3D printing. So that's certainly something looking forward to exchange and maybe collaborate here with some strong chemical partners.
Okay, then we are getting a few more questions inside. So let's take one back from Laurent Nicolas.
Yes, so which amount of catalyst would you need to polymerize NEXTENE resin usually?
Well, the catalyst content is very, very low. We are talking about a few ppms of catalyst itself. The catalyst is dissolved in a component. So our system is a 2-component liquid system with a mixing ratio of 50:1. So 50 resin, 1 catalyst. But even within this one of catalyst, the actual catalyst content is very small, a few ppms. I cannot disclose the exact amount, but it's really negligible.
Okay, great. Another question from Mutlu Cezanne. I hope I pronounce it well. Which is more efficient to use, carbon fiber prepreg or carbon tape or fabric for winding processing?
Today we work with, along our projects, we are working with carbon tape or carbon fabric. We don't yet have a pre-preg solution.
Okay. Great.
And then there's a last one from Jens.
Yes, Jens Bölke again. How about UV stability?
Indeed, that's a good and classic question for our material. The UV stability is not great, and typically the parts must be protected from light, especially from a colorimetry point of view. The color will change with UV. It will not affect the mechanical or thermal properties. It will only, let's say, affect the surface aspect. So typically, body panels, for instance, are not mass colored; they are painted.
Okay, wonderful. Okay, so as far as I see it, Yannick, we have covered all questions. Is that correct?
That is correct.
Okay,
Yeah.
How many viewers do we still have?
Now we are at 26.
26, a slight drop.
27. It's
27,
moving up.
okay.
But when you speak, it goes up.
It's relatively stable. Thank you so much.
Yes.
Okay, Ralph, we will continue with Yannick for 4 minutes. What would be your call to action? What is your CTA at the end of the show? Just tell us what to do now.
Well, before to say what to do, I would like to say that there is still a lot of potential with the materials like NEXTENE. NEXTENE is a very young material. We are fighting on the market with materials that have been developed before the war, before World War II, or just after World War II. So the incumbent materials have a very long the R&D, let's say, history, while our material is only a few years, maximum 1 or 2 decades old in terms of pure R&D. So there is a lot of, let's say, improvements to still uncover and make together with the people who are watching us today. So really, NEXTENE type of material is the material of the 21st century, and I really would like to encourage you to be part of that story. And please contact us for discussing the application that you have in mind, and we'll be happy to look at it and develop a solution together.
Wonderful. Thank you so much, Ralph. And
thank you, Yannick.
Thanks for attending. Thanks for showing us your innovation. I wish you all the best with your startup. And, it's worthwhile to make this effort. It's a wonderful solution. I will take you off the stream right now, but please stay with us until the end. And I will now talk with Yannick about our upcoming event.
All right. Thank you very much.
So, Yannick, what
Yes.
are the good news? We are going to make a hybrid conference in Stade, Germany on the 18th of February. So you will be probably also a part of the personal presence. Yeah, we are still considering whether you will come up from Ingolstadt or Zurich to Stade. That is a long travel for you. So we will see. Some of our colleagues will be organizing and will be present in Stade, and most of our guests will be, broadcasted, invited in the virtual environment. And we will talk about, the state-of-the-art composites challenges. Can you tell us about the 4 themes that we are looking to cover?
Yeah, sure. So we decided to, of course, focus on some topics, and we for sure have other ideas for upcoming events afterward. But for this time, we will go into new mobility, because that's very actual, and we hear about every day about Lilium and co. So it will be about air mobility, but also, of course, ground mobility, urban mobility in general. Then we will move into also infrastructure construction, because that's from a volume point of view of material very interesting for the composites, where I guess composite can leverage a lot of the positive points to really bring sustainability here. we will also have also robotics, automation topics, because that is something also which there's a big shift, I guess, in the composite world to go from, let's say, the manual manufacturing to very highly automatized process lines. And last but not least, because we are not only about tech, but also about agility and how to bring technology and innovation to the people, to the users, it's something which we like very much, is all this agility, design thinking topics, which would be actually a fourth topic, which is not tech-oriented, but methodology-oriented.
Okay, so for anyone who is interested in our Composites Lounge Conference 2.0, and 2.0 stands for the hybrid version, there is a LinkedIn event on LinkedIn. So you see here maybe I can, no, I can't. So just make a note of this one, and we will put it in the comments, the link to our Composites Lounge. We have very favorable early bird prices right now. And we are also supported by the world's largest community in composites, that is the Composites United Association. And we have also sponsoring packages available. So if you want to sponsor us, it is a German-speaking conference, but if you want to sponsor us, please feel free to get in contact with me. We have already 63 participants in the event. And there's also the link here, as you can see, to the Composites Lounge, which I will press here. This is our website where you can see the program. The program is right now still in the making. We have a lot of speakers. We have contacted them, and we have a lot of approvals already. So we are right now filling in all these programs here. And you can buy your ticket at the end of this website. Yeah, hier jetzt anmelden. This is where you can get your ticket for a very, very favorable price. The early bird ends on the 31st of January. So hurry up and get your early bird ready. And as you can see, we have Composites United here. We got LZS from Dresden also working with us. Then Yannick's company, 90 Labs. Obviously my company, IMBEO. Pullcube from Jens, and Sigitech for Oliver's company, Livenko Daniel's company. We have, gathered up, and we are offering you this live event from the comfort of your home. So this is what we wanted to tell you guys at the end of our show. What we will do right now is, as we have invited Demeta and Ralf Hertel to our LinkedIn Live, we will continue these LinkedIn Lives as a warm-up to our conference in Stade every Thursday at 3 p.m. Please join us. Ralf was the only exception in the English language, so all the others will be in German language right now. But we are considering to make a similar thing in the international scene. But right now we will be in the German-speaking markets, that is Germany, Austria, and Switzerland. So next Thursday, please be aware that I have Oliver, Sigitech, and Professor Siebert here in the house. We will talk about pultrusion, and we will give you some updates on our conference in Stade. Yannick, anything else you want to say? What is your call to action?
I would say now it's the beginning of the year, so keep planning forward. I guess we are in for quite some hybrid events, but very selected events with a lot of experience now from last year. And call to action, keep innovating and really connect within each other. I guess we have to learn to speak more openly and to just bring in more innovations through connection.
Thank you, Andreas, for putting in the event. That's very kind of you. Thank you so much. Andreas will also join us in Stade in order to document our, travel and our first steps into the Composites Conference, hybrid conference formats. Thank you so much, everyone. So anyone who has joined us later during the show, this show is now ready for you in the replay. You can go back into the beginning in my profile. You can also watch it in YouTube. Just go on my profile, and you will see many LinkedIn Lives around composites, and many more are coming up in the future. Thanks for joining us. Yannick and Wilhelm Yannick Wilhelmin and I myself, we say goodbye to you now and see you hopefully next week, Thursday, 3 p.m. Bye-bye.
Au revoir, auf Wiedersehen.